Hello everyone. Thank you so much for joining us for the Pittsburgh Jug. Uh, we, uh, yeah, I mean, we haven't been as frequent as we would like to be with our Pittsburgh Jug sessions, but today we have like a great session planned for you all. We typically post all our upcoming events on the Pittsburgh Java meetup, and I think since our frequency has reduced, like do check out the meetup itself to get our upcoming event notifications. We also post on the Pittsburgh Java meetup on the Twitter handle, so you can also use that to follow about in general like Java news that we post. We would like to take a minute to just thank our sponsors, JFrog and BNY Mellon. And with that, I'm going to hand it off to Chandra. Chandra, if you can introduce yourself and you can take it away. You can start your screen share as well. I will stop sharing right away.
Great, thank you so much. Thank you, Pittsburgh Java User Group, Sirisha and Renat, for hosting me over here. I look forward to an interactive session. And just a brief introduction, my name is Chandra. I'm a Java champion since 2019. I work in the financial services industry, and I've been working with Java for quite a long time. And I'm very passionate about Maven. So I think that's a good, decent enough start. And with that, I'm going to share my screen and we can get started with the actual presentation. What I would like to do is in this presentation, if you have any questions, please don't hesitate, ask away right off, and we can take it forward from there. There is a time bound for this, but we can always stretch it a bit. I'm assuming Renat and Sirisha, if that's okay. But hopefully we'll complete this in about 45 minutes and leave room for questions and answers. That's the current hope at least. And with that, I'm going to get started with what the topic today is. Today, we'll talk about Apache Maven 4 and why it is awesome. So bear with me while I first minimize the Zoom cameras because that's going to obstruct what I'm looking at. Okay, so with that, my name is Chandra, and I said that today we'll talk about Apache Maven 4 and why it's awesome. But I do want to prepare you for Apache Maven itself. So I'm going to very briefly cover some amount of what Apache Maven is, what it does, etc., and we'll take it from there. So what is Apache Maven? We know that it is a powerful build management tool. It allows you to build projects and specifically Java projects, but more than that, it was built in Java and it's an open source project. And one of Maven's cool features is that it follows convention over configuration models. And we'll talk about that briefly. It allows for other languages to be built as well. So Maven is not just limited to Java, but it's primarily being used for Java. And by the way, throughout the session, you'll see my Twitter handle or whatever it's called now, X handle, all the way at the bottom. It's Guntur. So should you want to connect with me on this topic or any related topic, please feel free to communicate on Twitter. So what is convention over configuration? So Maven follows the approach of convention over configuration, which is a paradigm in itself. And basically, a conventional model implies that there are decisions that are pre-made for you, and you're allowed to customize and configure to move away from those decisions. So it satisfies what is known as the principle of least astonishment in that when you approach a Maven project, for most part, you understand how it is set up, you understand where things are, and you understand how it gets built. So that's typically not the case with other build management tools out there. I will not name those. But essentially what you find with Maven is that everything is very simply laid out and easy for you to immediately understand where to look for what. There are sensible assumptions that Maven makes, and you're allowed to customize and configure them over. It promotes common structures and flow in a project. And here is an example that you see in the image on the right is how a project structure typically looks like. There is a source under which there is a source main, and under main you have your programming language, Java in this case, and any resources that you would bundle along with your application. Parallel to main, you also have a test directory, and in this test directory, you still have Java code, only that it only runs when you test out your project. It does not go into your production hosted binaries that get built out of your Java code. Test resources have their own sections have their own resources, which may be different from the main production line Java resources. So that's what the distinction is. And at the root, you have what is called the pom.xml file, which is the instruction set for the build management. We will go into that in a little bit, but I just wanted to share that is the conventional structure of a Maven project. Can this be customized? Yes. Should you customize it? I don't think so, but if your project does demand that you customize it, it is possible to. So we'll go with that in a bit. But what is a POM? So a POM, is it a Pomeranian, pomegranate juice, or pom-poms? So what is a POM? POM is none of those. POM is a project object model. And the project object model lists several things such as the dependencies your project has, what plugins are needed to build your project, some of the properties associated with your project. There could be version numbers of individual dependencies. There could be some specific, values that you use within your build structures. You sort of embed them into your projects, etc. Can all be customized in the properties. POM-less inheritance details. So you could actually have a parentage, and we'll talk about that briefly. POM can have profiles, so you can build multiple avatars of your build. So you can have something that runs, let us say, a QA mode, you can run a production mode, etc. You can separate different profiles. Ideally, it's not recommended to use profiles heavily, but should your project need them, they are available there. So that's what a POM structure looks like, and we'll take a brief look at how a POM looks like. It's an XML file. As I mentioned, it's a pom.xml. And the XML file contains certain elements, for lack of a better word, that sort of describe your project and how it gets built and other artifacts that get generated out of it. Typically, you will find a model version for your POM. It is normally 4.0.0 in most of our existing world, and we'll talk about this. Each dependency that you build out of your project will have a group ID, an artifact ID, and version. These are typical coordinates. These are not the only coordinates, but these are typical coordinates that allow you to locate your binary or your artifact once it's created. And we'll talk about that briefly later. You can optionally specify a name for your project, otherwise one is created. You can have different kinds of packaging. We'll talk about that later. The properties, as I mentioned earlier. And then there are some other, build instructions, and you have other dependency management sections, etc., which we'll try to cover as we go along. What are the benefits of using Apache Maven over other products, right? So that's something useful to know if you're coming into Maven from let us say some other build tool, or you're freshly approaching build management in a Java project. Apache Maven allows you the following benefits. You get visibility. That is, when you build your product, you know exactly what was built, how it was built, when it was built, etc. So timestamps, how it got built, what dependencies were pulled in, etc. You get reusability. You can repeat your builds often and expect the same results, right? So you have composition and hierarchies that you can reuse in other parts of your code as well. You get verifiability in that you can also have your build management tool run your tests and get some outputs out of those and verify that those outputs are always correct. You get reproducibility, which is alongside reusability, allows you to repeat your builds. You get maintainability, which means you can manage your builds. And by maintainability, I mean you can sort of chunk your builds into sections, and you can also create profiles. So there are different kinds of maintenance structures that you can evolve in a Maven project. And then comprehensibility being the key. You can very easily understand the build process. And what do I mean by this? In that, if you are, as a developer, as a human, are looking at a Maven POM XML file, chances are you will find it very easy to understand compared to other build tools which have scripting mechanisms, which may develop more complex structures. When you have more complexity, Maven does provide you abilities to sort of customize your build. But in general, for an IDE or for a developer who's viewing this POM XML file, it is much more easier to understand what the Maven POM is doing. So that's one very big benefit of Apache Maven over, say, other build tools or build management tools out there. How does it work? And this is a key section to understand even before we go into Apache Maven 4. So 4, 3, they all work almost the same way. So let's take a quick look. I have some graphics. They're shared over several slides, and we'll try to go over it in a little bit of detail before we go into Apache Maven 4. So how does Apache Maven work? So you have your project, which is in this gray box, and your source code is in that black little box within the gray box. And there are notes that I have on the side. Should you watch this presentation later, or should you have access to the slides, maybe the notes will help. But for now, you don't need to refer to the notes because I'm going to verbally state everything that is in the notes there. On the side, towards the bottom, you'll notice that there is an internet Maven repository, and we'll cover that in a minute as well. So in order for you to use Maven, you'll first create what is called a project object model, shown in the red box. And in the red box, you'll have several components we talked about when we first described the POM. There is assemblage structures, there's dependencies, plugins, profiles, and they're marked in gray because it's generally not recommended to use profiles, but you are allowed to have those. And then you have build lifecycle and build phases that are a part of Maven and how it builds your project for you. Apache Maven is the tool that we use. So you download this. There is a binary file. Once you download this binary file and install it on your computing device, you are able to access the project object model through some commands. And the typical command you use is a Maven MVN, followed by whatever commands you use. A typical command is a Maven clean verify, Maven clean compile, Maven clean install, etc. So we are probably very used to typing these commands in, but they have different purposes when you execute different commands. So when you first invoke Apache Maven with the set of commands on a project object model, it looks for the project object model, which is what number one is. And then it sort of assembles what is known as an effective POM. An effective POM is nothing but taking whatever you have provided as an instruction set and applying it or superimposing it upon what the conventions are. So you get a fully qualified POM XML file with everything defaulted and your override superimposed on top of it. So it produces the sensible defaults and allows you to override the sensible defaults. So this POM that gets produced cannot be modified. It's produced sort of in memory. That's the best way to think about it. And you have no way to customize this once it's produced, right? It is a full set of what Maven will use to build your project. So that's how you understand an effective POM. And then we will talk about this Internet Maven repository. So when you build your project, you may have certain code, but your code may depend on libraries. So in the past, before we had build tools, we would probably download these jar files, put them and package them together, and somehow put them on the class path and have them access our source code for us to be able to get the classes from these jar files. With Apache Maven, what you go to an Internet Maven repository, and there's a chat coming up. If there are any questions, can you please let me know what the chat is about? Is this?
I'll let you know.
Okay.
I'll let you know. Yeah.
Okay, great. So suddenly something popped up on my screen. My apologies. So an Internet Maven repository is where all your and any dependent libraries that you use are hosted. And these dependent libraries are hosted and navigated to using the coordinates that we talked about when we were looking at the POM structure XML. There is a group ID, an artifact ID, and a version. These are three base coordinates that you can use to sort of isolate and pinpoint your specific dependency and pull it. So we'll take a look at that later. In addition, you can also have the same structures be available on your local repository and local cache. So the first time when you use Apache Maven, it sort of downloads whatever you require. And the next subsequent builds, if nothing changes, it will try to reuse what's available in your local cache. This local cache can be flushed. You can actually physically go delete this local cache, or you can force Maven to upgrade the cache on demand. So all this happens, but there are dependencies that are available on the internet. You specify the location of where you go to this, which repository this is. You provide a URL, and this URL is then sought to get all the dependencies that you look for in your project. And these dependencies and plugins are pulled down. So that is where the dependencies in the plugin section come in. Maven lists all the dependencies and plugins that you use for your project, right? It includes all the defaults for the non-configured plugins. For example, when you create a Java project, you don't have to specify a Maven compiler plugin, typically, right? When you don't, Maven is going to provide a default compiler plugin. Its version may be outdated, but it will provide one for you, right? Similarly, you may have a Maven clean plugin, which allows you to clean all the previous build artifacts that will be built in from the conventions if you don't specify any more modern version of it. So these are things that Maven does for you as a part of the effective POM, and they are available. And when you run a Maven clean verify, for example, these dependencies are pulled in from the Internet Maven repository for the first time, and from subsequent builds onwards from your local repository, right? The next thing Maven does is when the commands are executed, it looks for profiles. If there are profiles, it will try to activate the profiles that are included. So it will look for profiles that are active and run those, or the profiles that you specify on the command line are picked up and run. Profiles are nothing but the same content of a build instruction that you have in a regular Maven POM file, but they are specific for certain conditions. So conditional build instructions are put into profiles. So you can have different profiles, or you can completely ignore profiles and just have one single build mechanism. Typically, it is recommended that you don't use profiles, but if you do, they do provide additional superimposition of build instructions on top of even what you declare. So Maven provides you a lot of flexibility in this matter. And then there are life cycles. So Maven works on life cycles. So there are different kinds of life cycles in Maven. There is a clean life cycle. There is a default life cycle, which doesn't have a name per se. And then there is a site life cycle, which allows you to generate site reports and reporting plugin infrastructures. So Maven provides you all this. So when you do this, when you execute your commands, Maven pulls all the dependencies and plugins that your project requires from either the Internet Maven repository or from your local cache. And once the build is completed, it produces some artifacts which it can optionally push back to either your local repository or to the Internet Maven repository. Depends upon the command you're running. If you were to, let us say, run a Maven clean verify, nothing gets pushed. If you were to run a Maven clean install, a package is produced and pushed to your local repository. Or if you have some section set up where you instruct where it should be pushed to, the artifact can be pushed to a certain external location as well. And that's how Maven typically works. So this is the complete structure of how Maven would work. You have Apache Maven, you point it to your project object model, the POM file, and you run a specific set of commands. An effective POM gets produced. The dependencies and plugins you use get listed. And then once the commands get executed, it fetches all your dependencies. It does resolution of transitive dependencies. It does pull of plugins, etc. Runs your build commands. And once those build commands are run, you can optionally deposit a final output to some location, such as your local repository or to the Internet Maven repository. So that's how Maven works. So I'm going to quickly stop here and ask if there are any questions about anything I've shared so far.
I don't see anything on the chat. I think you can proceed, unless someone wants to raise their hand and ask a question.
Okay, great. Thank you.
Yeah.
All right, so we did talk a little bit about effective POM. What is it? So an effective POM is basically an assembly of execution steps, properties, and profiles that are in your POM XML file and what is provided as sensible defaults below that. So the sensible defaults are superimposed with whatever you configure, and that is what your effective POM is. It is the content that Maven can execute the project for, and it has an exhaustive set of dependencies and plugins that can be used in the build. Right, so it basically lists everything that you have as a dependency and all the dependencies that are, I guess, baked into whatever defaults that Maven provides. And this effective POM is what is ready for execution by the Maven executable. So it takes your instruction set, it amalgamates it with whatever instruction sets that are default available, and produces what is known as an effective POM, which is read-only. That is what is executed by Maven when the build commands are reached. So how is the effective POM created? So there are several steps involved, and I have some little icons on the side towards your right, and there are certain icons which indicate what you should change and what you shouldn't change. So the first two, for example, the Maven internal defaults and the Maven base POM are something you cannot ideally change unless you go tweak the Maven jar file itself. So I would avoid doing that. But there are a certain amount of, I guess, base configurations that you can pull from the internal defaults on the base POM. In addition to that, there are two settings files. One of them is located under your Maven installation. So where you install Maven on your computing device, there is a settings XML file. This settings XML file should ideally never be changed by you. If you work in a corporate, maybe the corporate can change it while they produce a binary for you for Apache Maven installation. But in a typical world, you don't ever go change the global settings. It is usually not recommended because different projects may have different settings altogether. So avoid touching this. If you are, be very aware of what you're doing. But usually this is not a file anybody modifies on a regular basis. What people do modify once in a while is a Maven user settings file. And this is once in a while because this typically points to where you're pulling your, I guess, internet repository locations from. So you specify your, I guess, dependency internet repository location here. You specify some, I guess, different kinds of, I guess, rules you use for your builds, such as, is this a snapshot only build? Is this a production quality build? What do I allow as dependencies? What do I not allow as dependencies across all my projects? That's what is specified in the user settings file. So once again, this is not something you modify on a very regular basis, but this is something you're allowed to modify once in a while in order to sort of set it up to whatever builds you're doing or whatever project's nature is for what you're building right now. What you would ideally go and modify is the Maven project POM, which is the second to last, I guess, vertical that you see. And occasionally you may also modify the parent or bill of materials POM, which we'll cover in a bit. But these are the two POMs that you heavily rely upon in order to tweak and configure your Maven build. An amalgamation of all these is what is called an effective POM, which you obviously cannot change because it's read-only. It is generated and it's read-only, so you cannot change that. So the gray boxes are the ones you can potentially change. The black boxes are something you should not change or cannot change. And within the gray boxes, the one with the flags, the red flag and the checkered flag are something that you should be very, I guess, concerned about when you change, but the green flags are some things you're allowed to change as often as you need. So that's the basic structure of an effective POM. It amalgamates all these from different sources and produces one single effective POM for you. There are different kinds of POM hierarchies, and in the previous, I guess, slide, we did show that there is a parent and bill of materials POM. So let's quickly delve into what those are. So you have different kinds of, I guess, hierarchies allowed in Maven. There is what is called a parentage. A parent POM is basically something that sits above your POM, and you declare it as your parent. So essentially, you're inheriting dependencies, plugins, and properties from some other POM that exists, and you are able to pull those into your own POM. So that's one very simple usage where the inheritance is where you declare a parent. And Maven works on the principle that a parent and child have to know each other. It is not necessary that it's a one-way relationship, so you should always be aware of that. When you declare some POM as your parent, the parent has no idea that you exist, and that is something useful to know, right? So you declare a parent, and then you are aware of it being a parent, and you can pull from it, but the parent POM has no awareness that you exist. Okay, and that is the parentage. The next kind of, I guess, hierarchy you can look at is the central vertical, where you have aggregation POMs or reactor POMs. An aggregation POM is usually used for, I guess, build structures, where you can specify different modules that need to get built. Now, when you specify a list of modules, be aware that just because I listed them as module 1, 2, 3, 4 in my aggregate POM, that they will get executed in that order. Maven will decide your order. You should never rely upon the order that is listed in an aggregate POM, but these modules do exist and will get built. So when you invoke commands on the aggregate POM, the exact same command that you use, for instance, a Maven clean install run on an aggregate POM, will include a run of the Maven clean install on each of the module POMs listed. And that's all there is to it. Now, the order in which they get executed is determined by Maven and not by the order in which you specified them. So be aware of that, right? So you should never take for granted that just because you listed the modules in a certain way, that they get executed in the same order. And aggregation is just a means of aggregating, for lack of a better word. It does not specify the order of execution. The third is essentially, and by the way, in an aggregation POM, the parent knows the children, but the children don't know the parent. So I can independently go and execute a module 1.pom, but when I execute an aggregate POM, I know the modules that I'm executing. The module has no awareness, it's a part of an aggregate POM. So in this case, the parent knows the child, but the child does not know the parent. So that's something useful to know. The third model is a bill of materials POM, which is slightly different from the first two. A bill of materials POM specifies your dependencies in your dependency management sections. Your dependencies are essentially what you use in your project as dependencies. And a dependency management section is used to control the versions that you pull for it. A dependency management section allows you to specify a specific version that multiple projects can use. So in your projects, you just specify the group ID and artifact ID. You leave the version alone. You don't specify the version. And whatever is specified in the dependency management gets pulled into your project's version for that dependency. You can override it, obviously, on a per project basis. So if you had a dependency set with a certain version in a management section, and then you overwrite and create a separate version for your specific project, you will be using whatever is specified in your project versus what is in the dependency management section. However, if you don't provide anything, it will pull from whatever is in the dependency management section. So it is a best practice to use. But in this case, bill of material POM is very similar to the parent POM in that it has no awareness of what children it has. The child POMs know that a bill of materials POM exists and can pull from it, but the bill of materials POM itself has no awareness of who's using it. Okay, so that is something useful to know. And should you have any questions about this, we can approach this at the end of this session as well. Okay. The same thing in XML excerpts is the first one is a parentage where I specify parent. If you can read the highlighted section, I know it's a very small font. I tried to be as, I guess, large fonted as I could, but you see that we specify a parent and we pull from that parent. So whatever is described in that parent in terms of dependencies, properties, etc., can get pulled into my project because a parent is specified. You will notice that when I specify a parent, I no longer need to specify a group ID. And technically, I mean, I could get away not specifying a version, but we'll talk about that later. In an aggregation, the central vertical, you'll notice that I specify different versions. There's a datetime fetcher, there's a greeting and a greeting generator, 3 different modules that I'm executing when I execute this POM. So all I'm doing is grouping together what 3 artifacts or what 3 projects should be built together. I'm not specifying the order, I'm just telling Maven, I need whatever command I run on the aggregation to be run across these 3 modules. in whatever order you decide. And that's what Maven is going to do. It will decide the order and execute it as is optimal. The bill of materials POM, on the other hand, just specifies your dependencies and dependency management sections, and you pull it in via an import. So when you import a bill of materials, all the dependencies and dependency management sections of that POM, the bill of materials POM, is incorporated into your POM. A typical example is a Spring. I guess Spring Boot and Spring Framework have their own bill of materials POMs. And what they do is specify what versions of the dependencies work well together. So they've tested it out. And when you use a specific version of Spring, the BOM for that Spring version pulls in all the dependencies that work well with that version of Spring. Right. And that's what a bill of materials POM does for you. And it's not just that Spring has it, you can create your own bill of materials as well. Right. And we'll see how Apache Maven 4 has helped us get there as well. So that's another thing to know. Any questions on the POM hierarchy so far? Is everybody okay with what's been shared?
Seems like it.
Okay.
Seems
great.
like it. Yeah.
Okay, great.
Yeah.
Awesome. So now that we've covered some ground, and if there are no questions, I'd like to jump into what the Maven 3.x versus 4.x, I guess the purpose of this session is. So there are a few issues with Apache Maven 3, and we'll not just talk about it in terms of PowerPoint slides. We'll actually go into actual code and see how it works and what the pain points are. So there are about 5 points that I want to cover. There's a lot more than this. So please don't take this as a very complete, I guess, justification of why Apache Maven 4. Maven 4 is awesome. That is what the title of this talk is. And I do sort of agree that Apache Maven 4 solves a lot more problems than what are listed here. But these are core pain points that we as users feel. A lot of other benefits are what the handlers or the creators of Apache Maven have found and have resolved. So we'll not be covering those right now. So it is very painful to maintain versions in multi-module projects. Any of you who have worked in multi-module with Apache Maven, or for that matter, any other build tool, know how hard it is to maintain versions when you have, let us say, upgrading to the next version of whatever product. You have to use certain plugins. You have to create your own mojos or some other way to handle this. It is not easy. And we'll talk about that in a minute. I'm going to go into more details. There's a full slide for this, so bear with me. And then there is no way to specify build info and consumer info. We'll take a look at that in a minute. And then handling versions of dependency or sibling modules. For example, you have modules, 2 modules within a single, I guess, aggregator or a parent, and you're trying to build them both. And the version numbers of one is dependent on the other. When you build the next version of this, you have to specify the previous version or do some hack in order to get the latest version, right? And then if the build order is messed up, you cannot build them at all. It can create cyclical dependencies as well. It is a pain point, and we'll take a look at that in code. Another thing that I mentioned as a benefit of Apache Maven is that it provides you sensible defaults. Now, the sensible defaults it provides may have an older version of whatever dependency or plugin you're using, and maybe you need a more modern version. Sometimes we get away with it, sometimes we fail, and whenever we fail, we go update that version number of a specific plugin or a dependency, and we think we are in business, right? There was no way for us to know that we were using default versions of plugins, right? Apache Maven 3 did not allow this. And then creating a bill of materials was never really possible in Apache Maven 3. What we did was we created a packaging of a POM, and we would specify that as a bill of materials and use that, and we would import it. So that's another drawback in Apache Maven 3. So maintaining child versions, the first of these. So there are 5 of them, and I'm going to list some details about the 5 of them. So you know if you still use Apache Maven 3, there are workarounds that you can use. I would prefer you don't use them and go to Apache Maven 4, but should you be stuck with Maven 3 for now, you have 2 plugins that allow you to get away with maintaining child module versions. There is something called a Maven Flatten Maven plugin by Codehouse, and there's a CI-friendly Flatten Maven plugin by Outbrain. And both of these plugins allow you to sort of generate new version numbers for child modules. They use something called a release, a revision, and they use this revision property in order to sort of give your child modules a new version number as soon as you upgrade, let us say, the parent version. Right, so that's one possibility. They have issues. Flatten Maven plugin has issues with profile interpolations, which basically mean that when you have a profile and it interpolates some values such as tokens or properties, it doesn't do well with that. And it requires a third-party plugin to be incorporated in your POM XML file, which adds to a little bit more of a confusion. The same problem exists with the Outbrain CI-friendly Flatten Maven plugin as well. But in addition to that, While it has this issue, it does solve the issue of profile interpolation because it's CI friendly, which is where you have a build server, and on this build server, you're building your code, right? That's what the problem with the Flatten Maven plugin was. And both of these plugins use a revision property to set the version values. Now, why would I need to have a revision property from a plugin when it could be incorporated in Apache Maven itself, which is what Apache Maven 4 fixes. Now, the build info versus consumption info is a pretty complex topic once you think about it. When you create your Apache Maven file, you specify a lot of things in it. You specify the dependencies that you need, which is nice. You also specify some properties, you specify modules, you specify, let us say, your CI server information, your SCM information, your developer information, build instructions on how to build your code, etc., all of which is irrelevant to a consumer. Right? A consumer doesn't need to know all this. All they need to do is get your dependency and find out if it has any further dependencies that they need to pull. They don't need everything that is in your POM XML file. And thus far, there was no easy way in order for us to segregate between what was a build instruction and what was a dependency or a consumer-ready instruction. Right? And this problem doesn't exist now. It has existed for a while, and the solutions also existed for a while. The same two plugins that we saw in the previous slide do help. The Flatten Maven plugin and the CI-friendly Flatten Maven plugin still come in handy. They do a separation of your build instructions from what the consumer instructions are, right? And with both of these plugins, it would create two POM files. One was the build POM file, and the other was a consumer POM file. And we'll take a look at that in our actual, I guess, I'm going to open up my terminal and show you that there are two different POM files that are created, right? So that's something useful to know. Now, a POM can be reduced in content and have only details that are relevant to a consumer and be shipped off. Whereas the other POM, a build POM, allows for Maven itself to build the code on your local machine. And that is a possibility now. The versions of, I guess, dependency or versions of sibling modules was a pain point, and there were different ways in which they were handled. Most typical ways that I have seen is either use the most recent version of all the siblings, so go manually edit, or hardcode the versions during testing, where you say, I only want this version. So even if a new version is built, don't use that. Just use my hard-coded version. And then you go test individual components like this. Every time you make a change to one module, you essentially just hard-code the remaining sibling versions in that particular module and test with that, right? It is painful. So there is no easy solution. It is just that people would find out different ways, creative to solve this. And there are times when people also use the project.version property to do this, right? So when they want the latest versions, they build everything together, and then they use the project.version. It could lead to some cyclical dependencies also, and that does cause pain points. And staying current with the plugin versions, I already mentioned, we are developers. We are, I guess, by definition, lazy. And sometimes we just take what is given to us for free without even thinking it through because it just works for now, right? The Maven compiler plugin being one of them, Maven clean plugin being one of them, right? So when we get the default versions, they are older. And sometimes we don't get all the benefits of a more newer version of the plugin, right? It could be just that the performance has been improved, or maybe some vulnerability has been fixed, etc. We don't avail of those because we're still relying on the defaults that Maven provides. The best practice is ideally to set exact versions of all plugins, but since we are lazy, we don't do this, right? In Apache Maven 3, there was no way for us to identify that we were using a default version of the plugin, right? More modern, like Apache Maven 4 allows you to identify this. They provide a warning. And in addition, although I've not mentioned this anywhere, you can actually fail your builds on warnings in Apache Maven 4, which is super cool. So you can actually have a more hygienic POM XML file going forward. Now, the last thing that I want to talk about was creating a bill of materials. We saw a bill of materials. It's essentially a POM that declares your dependencies and dependency management sections, and you pull the bill of materials into your own project via an import, therefore pulling in all the dependencies and the dependency management versions into your product. There was no BOM packaging in Apache Maven 3, and therefore you would create a POM packaging, a project object model packaging, and declare it as a BOM. Right, you would give it a name -BOM so people would know that it's a bill of materials and not a POM as in a project object model. So that is something that was a pain point. It has been addressed in Apache Maven 4. So before we go into the 4.x, I just wanted to take a quick minute and see if anyone had any questions about what was asked, what was shared about Apache Maven 3 so far.
There is actually one question.
Sure.
on the chat.
Sure.
Chandra, would you have examples of projects where each of these POM hierarchy would make sense? Thanks for including an example on bill of materials, Spring. I think this was around that subject where you were talking about project hierarchy, aggregation POMs, and bill of materials.
Great. That's an excellent question, and thank you whoever asked. So essentially, the question, if I read it correctly, is how do I make a decision on when to use a parent versus when to use aggregator and when to use a bill of materials POM? If that is the question, the answer is when you are working in a product or a project and it has several components to it, and these components share content. For example, you have a major, I guess, top level project, and it has some child projects which are all associated with one another and go hand in hand. They just share some amount of dependencies, they share some amount of properties, and you want to keep them together. They share a Java version, they all build on the same Java version, they use the same properties. A parentage is probably the best thing to do, right? It works because it basically ties everything together and you can share the commonalities in a parent. That's parents. When you have a project with, let us say, multiple modules and you want different build structures, let us say I have 10 modules in my project and I can get away just building the 3 modules. And I'll give you an example. You have a N-tier architecture where you have your UI, you have your, I guess, server-side code, and then you have your, I guess, application layer code, your persistence code, etc., in separate modules, and you just want to build the backend. You don't care about the front end while you're testing out the backend. Then you can create an aggregator POM that just does the backend. You can create another aggregator POM that just tests the front end, right? Not just test or build. So you can do this. So aggregators are very useful when you want to sort of limit the number of modules or specify the modules that you want built together. That's the purpose of an aggregator POM. A bill of material POM is much more of a concept across multiple projects, right? So you want to ensure that your team, which is handling 10 projects, should stay consistent in the dependency versions that they use. Take, for example, the log4j incident that happened about 2 years ago. Now, if every POM file had mentioned the log4j as a dependency, then there was a lot of work for all of us to go back and go change it across every project. If we had a bill of materials POM, on the other hand, and we had just specified the dependency there, an upgrade to the bill of materials POM would have brought in a fresh dependency on all the projects that you had. Now, this bill of materials POM has no idea that you exist as a project, but you could specify a common list that is used across in all the projects. So that's where a bill of material POM comes in. Another example is Spring itself, right? Where Spring framework comes out and they have like tens of hundreds of dependencies in them that Spring uses for whatever product that you use. And let's not even take Spring, let's take Spring Boot. It may have a lot of dependencies. Now, if every time I upgrade Spring and Spring Boot, for example, if I upgrade it, I will be in a hoop to go upgrade all the dependencies that work with it, right? And that's a pain for me because I'll have to test those again and again repeatedly. Versus if the Spring team has already tested a set of dependencies that work well with that version of Spring or Spring Boot, all I'm doing is pulling them down, and I have a fresh set of dependencies that work well together, and I don't have to worry about it. That's where a bill of material POM comes in handy. I don't know if that answers the question, but if it doesn't, please let me know.
I'll keep an eye out on the chat, but I think that was a pretty comprehensive answer. Even if you didn't answer that question, we all learned a little bit more about the use cases. There are actually, okay, yeah, I think that made sense as what I got from the chat. We have another question. What is the best way to identify unused libraries in a given pom.xml file?
Okay, so there are different tools that allow you to do that. If you use IntelliJ IDEA, for example, it has unused dependencies show up, right? It'll show you the gray squiggly lines. You can go pull that out. There was a product known as Telltale, which would actually identify this. It was from, I guess, the Red Hat JBoss source code. I don't know if it still exists. But more importantly, you have dependency graphs that you can create, either text based on a command line or in, I guess, your IDE. I use IntelliJ Ultimate, and therefore I have it for free, which shows you the dependency graphs and shows you like hanging chads of dependencies that you don't use. Different tools, but you'll need to evaluate. The best way to do it, like treat your POM with hygiene, right? So go look at a dependency, see its use and purpose, and if it doesn't have a use and purpose, it should be going away. There are also scopes that you could use for certain dependencies. Like, do you really need it at the scope you're setting it at? Does it need to be at runtime? Is it only a compile time dependency? Is it a test time dependency? Right? Doing all this reduces the final artifact that you produce, and also reduces the amount of potential vulnerabilities you can get in your code. So there are different things, but there is no single solution to this problem, because in the end, you are the author of the POM, and Maven will only pull in what you tell it to pull in. So you having the discipline to determine whether a certain dependency exists or not is step one. There are some tools that help you evaluate it. Your IDE, IntelliJ IDEA Ultimate, does it for sure. I don't know what the other IDEs do. I haven't tried it much with them, but I know for a fact IntelliJ IDEA does this. And then, of course, you have your dependency trees that you can run from a command prompt, and it'll show you a list of dependencies that you use, right? And whatever is not in the list is obviously not used. And then there are other POM hygiene techniques you can use, as in excluding certain transitive dependencies because you have a better version of it, etc., or you don't need it, etc., are some things you can use. And certain dependencies you can mark as optional. So there are different ways in which you can approach this, but there is no single solution. There are a lot of tools Maven provides. It is for you to choose which ones you want to use. Awesome. Not sure if that answered the question, but I'm going to jump into the IDE for a bit. But should you have more questions, please either put it on the chat or connect with me on Twitter. Here's my Twitter handle, the @Guntur. We can always connect and have a conversation about it later. Awesome. So I just wanted to start by first sharing, this is not the window I want to share. This is the window I want to share. So we'll take an example of a Maven multi-module project here, right? The slide, whatever slides I'm showing are also linked in there, and there's all available on GitHub. For those of you who did not take it down, the GitHub link is also included here. So I'll paste this in the chat should anyone be interested in this later on. Okay, so back to the code. Here is the code. Essentially, this code, when it executes, provides this as an output, right? So it says either good morning, good afternoon, or good evening, depending on the time of the day, and mentions today's date. That's all we're doing, not much. So it's a very simple project, but it is a multi-module project in multiple ways, right? So there is a date time fetcher, which is the core product that we use. And all its job is to basically determine the time period as morning, afternoon, and night, and produces a date from it. Right? The greeting module takes the daytime fetcher and adds a hello, good morning, today is messages to it, and takes the date and creates the string for us. And the greeting generator has a main method that invokes the greeting, which further invokes the daytime fetcher. So it's a very simple project, and I can show you how the code looks like, but we'll get to that in a minute. So for this code, I'm just going to go to the project view, and bear with me, this code is small. This section font is small, but there are two versions of this project. There's a Maven Multi 3 and a Maven Multi 4. And both have the exact same code. If you look at it, they both have a datetime fetcher, they have a greeting and a greeting generator, and the code is very much the same. There is not much difference between the two. I just listed them as two separate modules because I run them with different versions of Maven. Now we'll see the difference. So that was the project. And before we go there, I just wanted to very quickly show you the difference between the build POM and the consumer POM that Maven 4 produces. So that's difference one that I wanted to share. So here is an example of what the difference would look like. In a build POM XML, you have your parent information specified. The consumer of your POM, the people who depend upon your artifact as a library or a dependency, don't care about the parent POM. So that is removed, right? So that no longer is required. Developers stay there because you want to know who the developers were, what the mailing lists were. The modules, you don't need the modules. Consumers don't need to know how this was built, what order it was built, or what modules were built while building this dependency that you're using. So that is removed. Your CI management, which is essentially how you build your project, right? Your continuous integration model, where you know, let's say a Jenkins server or a TeamCity build or whatever you use, a CI build of some sort, is not information a consumer cares about. So that is removed in a consumer POM. So what you see on the left, on the screen left, where I'm sort of having my mouse pointer right now, is the build POM XML that Maven uses to build. And what you see on the right is a consumer POM, which is what is delivered to the end consumer for their, continued use. What they would need to know is what your artifact coordinates are and what its further dependencies are as transitive dependencies, and they get carried over. You can see the dependencies section. What you'll also see is the distribution manager section is missing, because consumers don't need to know which repositories you're pushing this to. They already have access to your artifact, so they don't need your distribution management section, right? And this could be a bit sensitive because there are some passwords that are involved in this as well. So that is no longer a part of your, I guess, consumer POM. They don't need to know the properties. These are already interpolated into whatever build you had created. So the properties are meaningless and they are removed too. And then any dependency management section is not required by the consumer because your effective POM has effectively created all the dependencies with the right version numbers for you. So the dependency management section goes out of the window. And then there are further things, your plugin repositories. You don't need plugins for the consumers. So the plugin repository section doesn't even make any sense to convey to the consumers, and it gets removed. Your build instructions get removed because the consumer doesn't need to know how you built. They just need your artifact. They need to know what further dependencies you have. They don't need to know how you built your artifacts. So that gets removed. Your plugin management section is a part of the build again, gets removed. Plugins get removed. You don't need plugins for the consumers. Consumers don't need to know the reports that you generated out of your artifact. So that section gets removed. And then the profiles repeat everything that we talked about earlier because profiles are essentially just subsets of your full build instructions. So profiles repeat everything that we just saw, the property names, the build structures, the plugin managements, etc. Everything that was there in the, I guess, POM XML is repeated in the profile section for most part, and all those sections are removed. So the consumer gets nothing of this. So in the end, if I were to just scroll down, you will notice that there were 657 possible lines in a build POM, and what the consumer ends up getting is a fraction of that. And this is very important for multiple reasons, right? One, your POM file size is reduced. The consumer gets exactly what they need. They don't get anything more, and they get you can bypass all the, I guess, security concerns that you had with the previous POM XML file are no longer present in the consumer POM, right? So it's a much added benefit, and this is available thanks to Apache Maven 4. Now, one of the things which is very important to know is with Apache Maven 4, since the schema changed, you'll notice that certain sections are missing. Since the schema changed, it would cause issues if I reuse the same schema. So your consumer POM is a subset of the build POM, and therefore the schema still stays the same. So no matter what you use, and we'll see that we use a different version of the schema in Apache Maven 4, but your consumer POM is still a 4.0.0. Therefore, any existing mechanisms to pull these dependencies down does not have to go change itself right now, right? So they're still going to use the same schema as they were in the past. The model version still remains the same, 4.0.0, so you can still pull the artifacts as if they existed or were built from an older version of Maven. So backward compatibility is achieved because the consumer POM still shows a version number of 4.0.0. And please make a note of this. We'll show you an example where it doesn't anymore. But your consumer POM will always be the same version as it was in the past, at least for now. Therefore, all ecosystems that pull your dependencies are not impacted by you moving to a more modern version of Apache Maven. Okay. So if there are no further questions on this, or if there are questions, I'll take a minute and see if there are. Okay.
There was just a question that came up. So there are a lot of changes across the POM XML files. How does that affect with module and project migration? Could you use a Maven 3 POM with Maven 4? Would I need to make major changes to POM to work it with Maven 4? Actually, that was one of my questions as well. So yeah.
Wonderful. That's an excellent question. To summarize the question, basically, there have been a lot of changes, but if you notice, all the changes are a subset change. So nothing changed in terms of the POM layout, right? What you produce as a consumer POM still remains the same. In fact, you can conveniently use an Apache Maven 3 version POM for Apache Maven 4, and it will not complain at all. Nothing changes. It still works. So the backward compatibility exists. So you can directly lift and shift your current code and use Apache Maven 4 for most part. What you will notice is certain warnings will start popping up, right? And these warnings are because us as developers are lazy, and I'll show you an example of this later, and we may not have configured all the versions for our plugins. So if anything, it'll benefit you, it'll not cause you any damage, right? So it's a positive story to take. So I would not hesitate in moving to Apache Maven 4 when it comes out. Right now it's in alpha, but there is no significant change, and I can actually show you a demo if time permits that we can use a Maven 3 built POM XML file and continue executing it with Apache Maven 4, no issues at all. I don't know if that answers the question.
It does. You can continue. Yeah.
Okay, awesome. So here we are, the same project. So this is the child project of what we were seeing earlier. So this is the Apache Multi Maven 3, right? So there are two versions I created, one with Maven 3 and one with Maven 4. So we can actually take a look at both. So give me a second while I move the Zoom window a bit. And I want to verify with you, along with you, that I'm actually using the right version of Maven. So bear with me, the screen is small, but I'm using Apache Maven 396. I'm cheating a bit because here I said 388, but I'm using 396, which is fine. There's not much of a difference between the two. There are some subtle changes that don't matter to us as end users, but 396 is compatible with 388. So that being said, I'm going to minimize this again. And let's go back and take a look at the POM XML files. So here is my POM XML file for, I think the order got changed. Bear with me. Okay. So here is my Maven multi module. So in my Maven multi module, I have, I declare a group ID. I declare an artifact ID. And these are the coordinates that I use. The group ID being like a folder, artifact ID being a subfolder, and the version being the artifact's childmost folder, and your artifact resides under that. Think of it like a hierarchy of folders, and under this folder of version is where your final artifact, the jar file or the war file or the year file resides. In this case, the packaging is a POM packaging, which means there is no other artifact but a .pom file that is created. The root of the name of this project is Maven Multi, and it has some properties. I specify the JDK version. And by the way, Apache Maven 4 only works with Java 17 and upwards. So be aware of that. And then I specified the Java version, the JDK version. This may be used by other tools or plugins or whatever. So we really don't need it, but I specified it anyways. And then I specify the property for the JUnit Jupyter version. These are the modules I intend to build. And these are the dependencies. I have my JUnit Jupyter versions, and that's all I need for this product. So it's a very simple POM XML file. Now the fun begins. So I have my date time fetcher. I have no idea why my POMs got in a different order, but here's the date time fetcher. And my date time fetcher, if you notice, I specify the JUnit Jupyter API, and I don't specify any version here, but it picks it up because I have it in my parent POM. So it is inherited. I don't have to worry. It's a dependency management section. It'll get pulled in, although the ID is suddenly deciding that it's not right, but we'll do the build and we'll show you that this works fine. My next POM is my greeting POM, and the greeting POM basically has my date time fetcher as my dependency. So I depend on a previously created module in order to execute this. And because I have to use that particular module's version number, I specify it as a $project version. Now, this is problematic because if I don't build the datetime fetcher before I build the greeting POM, then I am stuck. I don't know what project version I'm using. I'm probably using a more modern version of this plugin. So now I depend on the datetime fetcher being built before I build the greeting, right? If I don't want that, then I would go and hard code this. And it's a change I have to make every time. And that's a pain point that I was trying to allude to earlier. The third one has a similar problem in that I depend on the greeting module and I still use the project version. Now I have doubled my dependencies in that my greeting project version, which has to match the datetime fetcher project version, it is required for me to build the greeting generator. And this was a problem like many of us face when we do our multi-module builds. We don't know how to specify the version numbers. Are there ways around it? Yes, you can use different plugins to do that, but it's quite confusing, right? And that was a pain point. Now, when I also build this project, I have no idea because I've not anywhere specified what version of, let us say, the Maven compiler plugin I use. Maybe I did over here, I specified 3.13, and I specified the Surefire plugin. Now, what version of the clean plugin did I use? I have no idea, right? It is never mentioned. So I'm relying on Maven's defaults in order to use whatever they give me, and I have no idea if that is the latest version I'm using. So let's build this project real quick, and we'll use Apache Maven 3 here because we confirmed that we are on Apache Maven 396, confirming it again. And we run this build and hope that this works. So I'm going to go open my, I guess, I'll just run it from here. I'm going to run a clean, and I'm going to run a verify. And when I run it, although it gave me all those errors in between, it goes ahead and pulls in all the dependencies, and the build is a success. So everything worked out fine. So I'm just going to minimize this portion and show you some of the content that is produced. So bear with me while I do that. Okay, so what happened? It downloaded a bunch of stuff. from Apache Maven because I did not have a repository set up. It downloaded Jupyter. It downloaded some things Maven needed. It deleted all my previous targets because I specified clean. And then it recompiled my source code, downloaded a few more Maven artifacts for the plugins, and then ran my build. I have a build jar produced. Everything is good. I'm awesome. So it all worked. I shouldn't be complaining at all. Now, what I'm going to do is stop here with the Maven 3, and I'm actually going to minimize this project. And I'm actually going to open the next Maven module, which is Maven 4. It looked very similar to what we saw before, right? So the same datetime fetcher, same greeting generator, and here we are. Now I'm going to show you that I'm using a more modern version of Maven, and the ID here is still not caught up, so bear with me. It'll show you errors, but it does work. So I'm using Maven 4, Alpha 13, the latest one out there. So this is what you'll get if you download it from the site right now, is I believe it is still on Alpha 13. So before we do anything else, I'm going to go run the same command here, and I'm going to show you some things that are different. And notice all of these have errors. Notice all of these have errors. I will get to that in a minute. Those are not errors. So let me run the clean verify again here, right? So give me a second. So I want to run the clean and verify, and let's go take a look at the output here. Okay, so I'm going to minimize as much as I can so we get more screen real estate. And let's go take a look at this. So of course, the first thing you notice, it's not showing me colors because Apache Maven 4 is not yet the final release. So IntelliJ hasn't caught up with that. Now, notice it started showing me some things. It says version not logged for your default bindings, Maven Clean plugin, because I did not specify the version for Maven Clean plugin. You should define the versions in the plugin management section. So it is now telling me that I'm doing something that is silly and I should avoid doing that. Likewise, for one of my submodules, it is telling me for my datetime fetcher, I am not binding these plugins, the clean, resources, jar plugins. I'm using the defaults that Maven provided. That was not possible in the previous version of Maven, and now I have this information. So it is helping me, and I could actually fail the build on warnings. Therefore, I always have POM hygiene, right? And then it also specified other warnings for, let us say, the third module, and so on, right? And this is awesome. Now, let us go take a look at the actual code to see what is different, right? And I want to do this in two ways. So I'm going to first show you the code here, is that I have the same code. The only difference is now my schema is 4.1.0, not 4.0.0. So that changed. And my schema location is also at a new place. It's 4.1.0. So Apache Maven 4 requires you to use 4.1.0 if you want to avail of the new features. Can I use 4.0.0 and get away with it? Yes, right? You will not avail of the new features. That is the change. So when you're ready to change, you'll upgrade the model version number and the schema number, and you will avail of the new changes. And the new changes being, my version is specified as a $ revision. Let's go back to the old code and see what it was specified as. So bear with me. Well, I go to the Maven Multi 3, and let's go to the Maven Multi real quick. And let's go see what it was. It was 1.0.0. And now in the more modern version of Maven, I specified it as $ revision. And there is a property over here that specifies the $ revision. Now, what is the benefit of this? Let's take a quick look at a command prompt, okay? And I'm going to go to my projects. So bear with me, conf, and I will increase the font size in a minute. Maven 4, Maven Multi. Thing is obstructing me. Give me a second. Okay. Multi 4, I'm here, right? So I'm going to just switch to my Maven 4. So we know that we are using MVN-V, and my font is increased. So you can see that I'm using Apache Maven 4.0.0. Okay. And now if I were to go ahead and build this code, so I'm going to just do a Maven clean, and bear with me, I'm doing something taboo. I'm going to call a Maven clean install. Should avoid doing Maven clean install, but because there are people on Twitter who may come and beat you up. Okay. And so will I, but that's a different story. And in here, you'll notice the colors as well. You'll notice that there are warnings and they show up in a different color. And it's so nice to see them, right? You can actually see that things are going wrong. And guess what? Without me specifying anything, it actually built version 1.0.0 because $ revision was set as a property to 1.0.0. Now, why is this CI friendly? Let's take a quick look. I just built version 1.0.0. So let's go verify that we actually built 1.0.0. So I have my repository. And in my repository, I have my none, CVG, Maven, And let us go take a look at Maven Multi. And you will notice that once I am able to show you, there's a version 1.0.0 build POM, and there's a 1.0.0 POM, two POMs, not the one. Okay, so that's one thing to remember. And then all my other dependencies got their version 1.0.0 jars built, right? So you'll have a greeting jar 1.0.0, and you will have a greeting generator jar 1.0.0, which is nice, very nice, right? But now let's take a look at the fun part of it. So let's go build Maven clean install, again, bear with me, -d revision equals 12.5.7. Okay, I picked up some random number and I built it. And this is where the CI friendly nature of Maven starts showing up. I just specified one version and it created all 12.5.7 values for me. So every version was upgraded, and we can take a look here. If we were to come back here, you notice that there is a 12.5.7 and there's a greeting jar created. There's a 12.5.7. There is a 12.5.7, and here is another 12.5.7. It has become very easy for you to manipulate versions with Apache Maven 4. That's a big selling point of Apache Maven 4. You didn't do much. Let's take a quick look at what we did. We specified the dollar revision for our Maven multi. And in my datetime fetcher, I don't even specify the project versions. Okay, I specified the parent here. I don't specify the versions anywhere. You don't notice me even putting a project.version anywhere, right? There is no version at all. It is gone. It assumes the version number from the parent if I don't specify it. Furthermore, if I go to my greeting, I don't specify the version, which we already talked about, and the model version is 4.1.0. But more importantly, in my dependency, I don't specify the version. It will pick up the version of whatever is currently being built. I don't have to go through hoops anymore. Same with greeting generator. It picks up the latest version. I don't have to specify the version numbers. It has made version management extremely simple for me. Okay, and that's useful to know. So that's one benefit. The other thing that I wanted to show you was, let's go to one of these POMs and take a look. So let's actually open maybe the greeting. Okay, let's go to the greeting, and we can use the 1.0 in this case. Doesn't really matter which one we're using. Let's take a look at these two POMs and compare them. Okay, so if I were to open this POM using, let us say, my text edit app, and hopefully I can increase the font here. Now, this is my build POM. This is the build instructions that I need in order to build, or the CI server needs in order to build. So it has a lot more content, such as parent. It has other things. If my project had more things, are all listed in the build POM. Now, if I were to go to the other POM, revert changes, if I were to go to my consumer POM, which is what should be uploaded with my artifact to whatever repository I'm going to, it doesn't need a parent. Who cares what the parent was? I get my group ID, artifact ID, and version. I get the dependency management, and I get the dependency. So I get exactly what a consumer needs in order to pull all the dependencies and transitives for my product, for my library, and nothing else. So all extraneous information is stripped out, and it gets sent out to the server, and the consumer can safely go and get your artifact without you having to worry about extraneous details that may or may not be required, and sometimes should not be required by a consumer, are all gone. Okay, and that is the big difference between Apache Maven 3 and 4. It has allowed to produce two different POM files, one that your Maven local installation needs, and the other that your consumers of your artifacts need, and they're separated out. The other thing that I want to show you while I'm here is, now Maven introduces what is called a BOM packaging directly. So you don't have to specify POM and go through hoops in order to declare it as a BOM by renaming it like Maven multi BOM. You don't have to do all that. You just have to specify it as a BOM packaging, and it is a bill of materials BOM. We did see a few things that Maven has changed. And just to go back and summarize, let's take a quick look. And let me know if I didn't cover some part of it. So bear with me while I try and go back here. So it was painful to maintain versions in multi-module projects. We just saw how version support has become awesome. There was no implicit way to separate build and consumer info. We just saw how two different POM files were created. We saw handling versions of dependency or sibling modules was a chore in Maven 3, and we saw with Maven 4, we didn't even specify the version numbers. It got pulled in. If you wanted to use a previous version, you can actually hard code that, or you can set another property. That's allowed. So up to you. We developers are lazy. we will continue being lazy. That Apache Maven cannot solve, but at least it now provides you with warnings when, or like you use default versions of plugins. Creating a bill of materials BOM is easy now because now there's a BOM packaging option. So I guess with that, I'll take any questions, but I think we're done with the presentation.
Oh, thank you so much, Chandra. That was really great. I mean, this is still an alpha release, right? I mean, are they expecting to release any more features, or is there some more that are in the works for the final cut?
Yeah, so I don't believe they're releasing any more features. It is just that they're baking in the features that they already have, and they're doing an excellent job with it. The team is amazing, and very accessible. So should you have questions, please reach out to them. They're happy to take your questions and give you as much, I guess, information as you would need.
Okay, yeah. So I don't have any questions. I'm looking at the chat. There was actually one on you mentioned profiles are not recommended. What are the alternatives, for example, to build for different environments?
Yeah, absolutely. And there are different ways to handle it. Yeah, the main reason why profiles are not recommended is because ideally for a Java project, there should be one way of building your code. The more profiles you put in, the chances are you will have maintenance issues down the line, right? Think about it. You're repeating sections of code with slight different modifications for you to do what should be achieved in one single build. You can actually do profiling, toggle switches, or even, let us say, your framework level profiles such as Spring. Spring provides you profiles are a much better option than your build tooling itself having a profiling section, right? So it's a recommendation, but it's not a hard and fast rule. Profiles do exist and people do build with profiles, but you should try and avoid it as much as you can if you have alternates. That is the only recommendation.
Yeah, okay. I hope that answers your question, Vijay. And I think, yeah, there was one more question on the target date for GA, if there is one. Do you know, Chandra, if there is actually a target date for Apache Maven? I've read some, I'm sorry, I'm not on video yet. Okay. I've actually read a post here or there, I think, where they said that since it's an open source project, they can't really guarantee any particular release date. I am not sure if they actually announced a
Yeah,
release
that is
date.
very much the case. We are not very sure of when it will get released, but there is definitely aspiration that this would get released soon.
Yeah.
So that's what I know. They are moved to Alpha 13, which is much better than where they were about a year ago. So we'll take that, but we don't know for sure when it'll happen.
Yeah. Yeah. Any other questions? Sham, you have a question. Do you want to just unmute and ask?
Hi, good evening. Thank you so much for this session. So a lot of companies are opting for Gradle, right? So is it advisable to move to Gradle from Maven, or we can continue to use Maven itself?
Yeah, that's an excellent question. I will not answer that directly, okay? Because I don't believe in there being holy battles between Gradle and Maven. They have their own individual benefits. I enjoy Gradle when I build my Android projects. I enjoy Gradle when I need the super flexibility that Gradle offers. I enjoy Apache Maven when it is, let us say, a corporate structure where I want consistency and where I want the IDE to immediately pick up my build file and generate my project for me. So I don't know if you're aware, if you pick up IntelliJ or Eclipse, you can point to your POM XML file and it'll actually launch your project with the right amount of, I guess, setup for you, right? It does become harder with scripted build tools, with Gradle or Ant, for that matter, right? The reason being not because they are bad tools, but because scriptability introduces another element of confusion that Maven doesn't have. Maven does very simple convention over convention, so it makes sense for a corporate world. But if you're building something that requires a lot of flexibility in the build tool, maybe you're working with, let us say, too many complex components, maybe you're building a mobile app, maybe you're building something for some other IoT device, maybe Gradle is a better option, right? So don't rule out all the arsenal in your chest. Use whatever is required. But I prefer using Apache Maven for corporate.
Cool. If there aren't any questions, then we can wrap up here. Thanks a lot, Chandra. Every single time your Maven sessions are always like, we always learn so much from that. So thank you once again.
Thank you. Thank you for the opportunity, and thank you everyone who was patient enough to listen. I appreciate it.
Yeah.
I'm sure everyone enjoyed it. Thank you so much. Thanks a lot, everyone. Have a great evening.
Yep. Have a great evening, and we'll have the recording up in the next week or two.
Perfect.
Thank
Perfect.
you.
Awesome. Thank you. Yeah. Bye-bye.
Bye.
Bye, guys.
Bye.
Bye.